All right, so there's many situations that arise in business and engineering that necessitate systems of linear inequalities. So the region in the XY plane that solves the system, so the part that's double shaded, often represents all of the viable solutions to the system. Viable meaning true solutions to the system. So being able to visualize this region can be extremely helpful. As always with modeling, it is important to really read the problems and understand the physical quantities involved. So in this first exercise, John mows yards for his father's landscaping business for $10 per hour and also works at a bakery for $15 per hour. He can work at most 52 hours per week during the summer. He needs to make at least $600 per week to cover his living expenses. So if John works 14 hours mowing and 30 hours at the bakery, does this satisfy all of the problem's constraints? So if he works 14 hours mowing and 30 hours, we know that 14 plus 30 is definitely less than 52. So we know, I guess we should probably write that down, that 14 plus 30 is 44. So it definitely solves the constraint of hours. But now we talk about money. So if he works 14 hours mowing lawns, he can make $10 per hour. And if he works 30 hours at the bakery where he makes $15 per hour, 14 times 10 is 140. 30 times 15 is 450. If I add that together, I get 590. So yes, it definitely is less than 52 hours, but no, the 590 is not at least $600. So if X represents the hours that John spends mowing and Y represents the hours he spends at the bakery, write a system of inequalities that describes this scenario. So let's talk about hours. So all of the hours mowing a lawn plus all of the hours spent at the bakery have to be at most 52 hours per week. So 52 is at most the hours per week that he can work. And we know that it's or equal to because he can work 52. The second equation talks about money. So we know that it's $10 per hour mowing lawns, $15 per hour at the bakery, and we're talking about $600. He needs to make at least, so $600, it has to be more than $600, but it can be at least $600. You can include $600. So if John must work a minimum of 10 hours for his father, will he be able to make enough money to cover his living expenses? Show the work that leads to your answer. So what you're assuming with this one is that if he's working 10 hours for his dad, then he's working the rest of the hours at the bakery. So if we're looking at 10 hours for his dad, that's 10 times the $10 he makes, which is $100. And if he's working 10 hours for dad, then he's working 42 hours at the bakery. So we can take those 42 hours and we're multiplying it by 15, which is 630. Add those together and he makes $730. So yes, he would satisfy all of his constraints if he worked the 42 hours at the bakery. So we're going to graph the system of inequalities with the help of a calculator. So what I'm going to do is I'm going to cover up part of this with a screenshot of what it looks like on the calculator, and then I'll show you how that actually transfers over to a sketch. So as you can see with this video, or with this image, I typed in exactly how the equations were over here. The first equation is in red, the second equation is in blue. And you will see how it covers up, it shades the blue above because y is more than, and it shades the red below because y is less than. So now we're going to sketch that on the axis on the next slide. So if we were to put that picture back in on this slide to be able to see what that looks like. This picture is down here. So we're looking at only the x-axis and the y-axis. So if I had the red line, and the red line is going at about 52, so let's say it's about right here, and then it goes down to 50. So the red line is kind of like this, and it shades everything below that line. And then we have the blue line where it is going slightly below and slightly farther over. So it's going like this, and it's shading everything above that. So the double covered area is in this little triangle right here. So John's father needs him to work a lot at the landscaping business. Show the point on the graph that corresponds to the greatest number of hours that he can work while still covering his expenses. So the greatest hours would be as far right as you can get, because on the right is the mowing. So the farthest right we can go would be right here. And I'm going to switch back to Desmos to find that coordinate point to be able to tell you what that is. And it is 36:16. So that means that he would be working 36 hours mowing the lawn and 16 hours at the bakery and still be making enough money to cover his expenses. So algebraically, we need to find the greatest number of hours that John can work for his father and still cover for his expenses. And we're going to have to explain how we found our answer, or show your algebra below. Since x stands for the hours of mowing, we need to solve for x. So we need to make both equations into y equals equations. So the first thing I'm going to have to do is take the x plus y, and instead of making it an inequality, we're going to have it just be an equal sign, and solve for y. So subtract x from each side, and y equals negative x plus 52. On the other side of that is the other equation, which is 10x plus 15y equals 600. We're going to subtract 10x. 15y equals negative 10x plus 600. We divide everything by 15. And y equals negative. And 10 over 15 can reduce down to 2/3 x, and 600 divided by 15 reduces down to 40. So if I want to solve for y, or for x, that means I don't want y in the equation anymore. And I can actually just make them equal to each other. So negative x plus 52 equals negative 2/3 x plus 40. I'm going to subtract 52 from each side. And I have negative 1x equals negative 2/3 x minus 12. And then we're going to add, we're going to add 2/3 x to each side. And I have negative 1/3 x. Oh, that should be 12, not 15. Equals negative 12. So I'm just going to rewrite it over here. Negative 1/3 x equals negative 12. To get rid of a fraction, you multiply by its reciprocal, which is the same thing as negative 3. And x equals, a negative times negative is positive. 12 times 3 is 36. You will notice that you have 36 here and you have 36 here. So we showed it both on the graph and algebraically, as painful as that was for me to do. All right, for each of the following, write a system of inequalities that models the problem. You do not need to solve the system. So the first one, Frank is putting together a bouquet of roses and daisies. He wants at least one rose and at least 2 more daisies than roses. Roses cost $4 each and daisies cost $2 each. Frank must spend $40 or less on the bouquet. So the first equation, we're talking about money, where roses cost $4 each, daisies cost 2, and he must spend 40 or less. So $4 for roses and $2 for daisies, and he cannot spend more than $40, but he can spend $40. The second equation is he talks about he wants at least one rose and at least 2 more daisies than roses. So those are multiple steps now. So he wants at least one rose. That's an equation all by itself. So he wants at least one rose. And then the third equation, he wants at least 2 more daisies than roses. So his daisies, he wants at least 2 more roses than every daisy. So there is your system of inequalities. Notice how there were 3 pieces to it. A diet food company is attempting to create a non-carb brownie composed entirely of fat and protein. The brownie must weigh at least 10 grams but have no more than 100 calories. Fat has 9 calories per gram and protein has 4 calories per gram. If X represents the weight in grams of protein and Y represents the weight in grams of fat, write the system. So the first one, we are talking about the fact that it needs at least 10 grams. So all of the protein plus all of the fat should be at least 10 grams. Then the second part, it can't have more than 100 calories. And fat has 9 and protein has 4. So 4 grams per protein, plus 9 grams per fat cannot be more than 100 grams or 100 calories total. The drama club at a local high school is wanting to raise money by putting on a play. They have only 500 seats in the auditorium, and they are using and are selling tickets for these seats of $5 per child's ticket and $10 per adult ticket. They must sell at least $2,000 worth. So, if X represents the number of children's tickets and Y represents the number of adult tickets, write a system of inequalities. So, all of the children plus all of the adult have to be less than 500 because there's only 500 seats, but you can include 500. But then adult tickets are $5, children's tickets are $5, adult tickets are $10, and they have to at least make $2,000. So now the drama club at a local high school is trying to raise money by putting on a play. They have only 500 seats in the auditorium that they're using and are selling tickets for these seats at $5 per child's ticket and $10 per adult. And my dog is freaking out. Cool. So if X is the number of children's tickets and Y is the number of adult tickets, they cannot have more than 500 sold because they can only fit 500 in the auditorium. And then we talk about price. So all of the money goes in its same equation, just like when we were making systems of equations. So inequalities are no different. $5 per children's ticket and $10 for adult ticket, but they want to make more than or at least $2,000. So using technology, sketch the region in the coordinate plane that represents solutions to the system of equations. So again, I'm going to use decimals to help me with that. So you will see that if I zoom in a bit on this, that it is going through the y-axis at 200 and what looks like 500. So one of the equations is going through at 200 in the y-axis, 400 in the x-axis. So about 200 here, 400 there. And then the other one, and it is shading everything up above it. And then the other one, it looks like the green line is crossing at 500. Whoops. Might help if I am using the pen tool, not the highlighter. At about 500, and then again a little past the 400, so at 500 again. And it is shading everything below that line. So it's everything in between these two. So the question is, if the students want to sell exactly 500 tickets and make exactly 2,000, how many of each ticket should they sell? So if they are selling 500 tickets and are making exactly 200, so it's in between there. How many of each ticket should they sell? Why is this answer not realistic? So what we're going to do is we're going to set up a system of equations. So we're going to use the inequalities from up above, and we are going to, I want to move this over to the side. So we're going to use the inequalities from up above, and we're going to make them equals instead of inequalities, so they will be a system of equations. So x plus y equals 500. So if they sell exactly 500, and they make exactly $2,000. So if I solve this by elimination, I can multiply this one by -5. So it becomes -5x, -5y equals -2,500. We're going to move this over, so 5x plus 10y equals 2,000. And now I have 5y equals -500 divided by 5. The reason why it's not true is because y equals -100. You cannot sell a negative number, so it is not true because of that negative number.